If you have two forces acting on an object, 3 newtons and 10 newtons, you'll remember from vectors that we can get a maximum force of the two added together, 3 plus 7, which is 10. And you can get a minimum force of 7 minus 3, which is going to equal 4 newtons. The maximum force is a result of them acting in the same direction, and the minimum is from them acting in the opposite direction. So anything in between is possible. So 4 newtons is the minimum, 10 is the maximum. Anything in between 6, so the only one that doesn't work out is 3 newtons. In which of the following circumstances are there unbalanced forces acting on a body? So here the car is traveling at constant velocity. Constant velocity means all forces are in balance on a flat road. A parachutist is falling at terminal velocity. We have learned that terminal velocity is a constant velocity, so therefore we have got no unbalanced forces. A box is stationary, no unbalanced forces. A ball is at the top of its projectile, stationary. After being thrown upwards, well, that's another stationary, but it seems to be a bit of a problem because this ball is not staying stationary. It was moving until the split second that it was stationary, and now it's going to move again. At all times while this ball is in free fall, it has a downward force of gravitational acceleration applied to it. There is a change in motion here. It is busy changing. Even though for that split second it's stationary, the ball at the top of its projectile is in the process of change, and therefore that is an unbalanced force that is acting on the object. So D is your correct answer. Isaac Newton throws an apple into the air. At the top of its projectile, the apple stops momentarily before returning to the ground. Which of the following three-body diagrams shows the forces on the apple at the top of its projectile? At the top of its projectile, there is only one force acting on it, and that is the gravitational force acting downwards. If it's not moving, it experiences no resistance whatsoever. The throw force will have occurred right at the beginning. It's not happening at the top of the projectile. A block of mass, 5 kilograms, is at rest on a smooth horizontal surface. If two forces, each 50 newtons, is applied to the block, what will happen to the block? So we can unpack this force here. We're not given an angle, so we're not going to calculate it. But we do know that the 50 newtons is the hypotenuse. Therefore, this force is less than 50 newtons, the upward force, and the downward force is also, at least, and the cross force is also 50 newtons, less than 50 newtons. So let's look at this. In the vertical plane, I've got 50 newtons acting downwards and less than 50 newtons acting upwards. That means that overall this body would have a force going downwards, but there's a table in the way which will give a normal, and therefore it's all going to stay still. In the horizontal direction, what are our forces? We've got a force of 50 to the right and less than 50 to the left, which means that the winner is the force to the right. So there will be an unbalanced force to the right. And the unbalanced force to the right causes an acceleration to the right. Here we've got a skydiver. His weight is 700 newtons. He's falling downward with a constant terminal velocity. That means that all the forces must be in balance. The forces acting on him, they must all be in balance with each other, so the upward and the downward force must be equal to each other. This upward force, by the way, is air friction. As a result of these three forces acting on an object, a point P is in equilibrium. The word equilibrium means balanced. So it's stationary, it's not moving. Which one is not true? Well, the result of the forces is zero is true. It's balanced, it's in equilibrium. These all appear, no one's told you that one's coming in the page, out the page, or anything like that, so they appear to all be within the same plane. Force 3 is the result of force 1 and 2. Force 1 and 2, if I were to draw a resultant, I would need to complete the parallelogram and draw a diagonal upwards. Force 3 is downwards, and therefore That is not true. And the sum of the components of all the forces is 0. Well, if all the forces are balanced, then the forces add up to 0, the components add up to 0. So C is your only incorrect option. Which of the following represents the arrows for a free body diagram, a bullet that has just left the barrel of the gun? Now, our bullet has come out of the gun. There's the barrel, and here's the bullet. So the bullet's in the middle of the air. There's no thrust force. The thrust force occurred over here. It is not happening to the bullet now that it is in the middle of nowhere. In the middle of nowhere, that bullet is experiencing two forces. One is its gravitational force, or weight, and the other one is it is encountering some air particles along the way, so it is experiencing some air friction, or if you prefer, air resistance. There is absolutely no force forcing it forward at all. The forward force happened back in the gun. When it's lying in free fall, it's D that is. Friction is best described as the force that opposes the motion and acts parallel to the surface. That's a definition. A normal force acts perpendicularly by a surface against an object that it is in contact with. Again, it is the definition. And if I've got a 1,500 kilogram block, I first need to change that into 1,5 kilograms. It's at rest on a rough horizontal surface. The coefficient of static friction is 0,26. What is the maximum static frictional force? Frictional force is equal to the coefficient of static friction, mass times gravitational acceleration. So it's 0,26 times by 9,8 times by the mass of the block, which is 1,5 kilograms, and I land up with an answer of 3,82 newtons.